Hello and welcome to my channel. Here is the part 2 of yet another series, Poetry in the Language of Excel, ForTran and Maths. Today we will not venture into any specific mathematical topic or its depth. Rather, we will see several seemingly uncorrelated topics and we will see that how they are all the same at some fundamental level. 7 such topics I will touch, and likely that they seem to be 7 rivers merge into the ocean of mathematics. We will see that particular thread of profound oneness that bring together all such 7 pearls into a single garland. Probability through probability, pattern out of random, and all those 7 pearls are arrangement, binomial expansion, combination, tossing coins, NMR spectra, error analysis and Pascal triangle, all under the same umbrella. So I would like to start with something childlike playing. Of course, at the end we must admit that it is not childish. Some of the childhood formula: a plus b whole square, a plus b whole cube, a plus b whole to the power 4, and as we know that we can write like this: a plus b whole to the power 0, anything to the power 0 is 1, but a plus b to the power 1, that means just a and b, and a plus b whole square is a square plus 2ab plus b square, and so on. And if I just take the number associated with the terms a square or ab or b square, a square b or ab square, etc., then just you take the numbers, we can call it the coefficient of this terms, like this. So it is 1, and then ab, that means 1 1, here 1 2 1 1 2 1, and similarly 1 3 3 1 for a plus b whole to the power cube, but the next a plus b whole to the power 4. So maybe that you are not remembering, it's not frequently used in fact, but as you know that the numbers for this last line is 1 4 6 4 1, right? So these are all very known to all of us. But is there any other way of looking at these expressions, any interpretation? So let us look at this. My point number 1, river number 1, arrangement. What do we mean by arrangement? So these are the formula and the corresponding numbers. Well, so for example, a plus b whole square, right? So square 2, that means I have taken 2 boxes as if, and I want to accommodate a square, that means 2 a's. So in 2 boxes, how you can accommodate 2 a's? There is only one way, a, right? If you exchange these two, again it remains all the same, a. So basically you are getting only one option, a. But what happens in the next case? That means ab case. Again 2 boxes are there because this is 2. So ab. Now you can put either a in one and b in the other, but also b in one and a in the other. That means you are having 2 options in this case. And similarly for b square, again like a square, you will get only one option. So you get 1 2 1 options. That means 1 2 1, right? So 1 2 1. So let us quickly examine the other 2 terms in the same footing. Say 3 and 3. So it is a square b. So the related formula is a plus b whole to the power 3. So we are choosing 3 boxes and we would like to put a square b or ab square, and how many ways we can arrange that option. Let us see. So 3 boxes and we have a square b, that means 2 a's and 1 b. So you see carefully, you can have only 3 options: b in the extreme right, b in the middle and b in the left. Only 3 options, right? And similarly, as you can assume that a square b and ab square, the result will be the same. In this case it is 1a and 2 b's, so the a is either in the extreme left or in the middle or in the right. So that is how we get by simple arrangement the number 1 3 3 1, etc. Well, other than this arrangement way, is there any direct formula or any shortcut way? Let us check. And that is our actual binomial expansion. Binomial expansion, because a plus b whole to the power n, any n, a and b. So binomial, that means we are taking 2 terms, a and b, and then we are expanding a plus b whole to the power n. So that we know as binomial expansion. This is somehow connected to our present problem. And of course the binomial expansion coefficients, that means those numbers, are given by NCR, and this is nothing but the formula for combination, as you know, NCR. That means how many ways you can pick up R objects out of N objects, where N of course greater than R, where R goes from 0 to N, right? So binomial expansion and combination, my two other rivers merging into the ocean of maths. So let us see a bit more. So these are the formulas and the corresponding numbers. Well, so first example, a plus b whole to the power 2, that means my n is 2 and r of course is 0 to n, that means 0, 1, 2, and the formula is NCR, so it should be 2C0, 2C1, 2C2. And what is 2C0, 2C1, 2C2? They are the formula. 2C0 is factorial 2 by factorial 0 into 2 minus 0 factorial, so that would give you simply 1. And again you can check that 2C2 and 2C0 are all the same and both are 1. Well, what about 2C1? 2C1 is, you see, 2C1, the formula again goes like factorial 2 by factorial 1 into 2 minus 1 factorial, because it NCR factorial is factorial n by r factorial into n minus r factorial. So it is 2. So we are getting 1 in the first and last case and 2 for the middle case. So it is 1, 2, 1, right? This is 1, 2, 1. And similarly, you can easily check what happens to the 1, 3, 3, 1, that is a plus b whole to the power 3 case. Here of course n is 3 and r goes from 0, 1, 2 and 3. So we have to evaluate these 4 terms, 3C0, 3C1, 3C2 and 3C3, and you can easily check that 3C0 and 3C3 are same and value is 1, and again 3C1 and 3C2 by same formula are same and the value is 3. So you are getting 1 in the first and last case and 3 in both for the middle two cases. So we get 1, 3, 3, 1. So thus we see that arrangements, binomial expansion and combinations all are giving the same formula, and you can extend it for a plus b whole to the power 4 case. There you will evaluate 5 terms and you will get 1, 4, 6, 4, 1, as I have shown already. So so far so good. Now the question is, I will now play a funny ForTran game. We will try to generate this binomial expansion coefficients by a simple program. So let us go for the program. It is binomial expansion. So let me open the file binomial, and here I will quickly show you the basic part of the program. We are evaluating, okay, NCR. Here I am telling it KCN, where n goes from 0 to k, and it will ask, the program will ask you to give you the k value, and then it will produce all the coefficients KC0, KC1 dot 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 KCK. Okay, so it will give you the binomial coefficient. So let me run the file and giving some input of k. Say I am asking for a plus b whole to the power say 4 or 3. So let me just give initially a small value, then we will see for relatively larger value, say 10. So it will take a few seconds, please bear with me. This is the program for binomial coefficient evaluation for k equals to, initially I will give k equals to 4. So a plus b whole to the power 4, and the formula should give you, okay, it gives all the value. So a plus b whole to the power 0, a plus b whole to the power 1, that is 1, 1, then 1, 2, 1, then 1, 3, 3, 1, and that I was asking for 1, 4, 6, 4, 1, that is being produced by this binomial expansion coefficient. And we can again run very quickly to give say a larger value, say 10. So I am giving k equal to 10, that means a plus b whole to the power 10, and that are the binomial coefficients, this last line binomial coefficients, right? I am producing here of course all 0 to 10, and it forms this kind of results. So next I will go back to my presentation again. Well, so we have generated the binomial coefficients by ForTran. So my next target is my river number 4, Pascal Triangle. So as I have just seen the results in ForTran output, it forms a triangle like thing. So actually this is Pascal triangle after the name of famous Blaise Pascal, and that gives you for 0, 1, 2, etc. up to 10, and these values that we have produced by our ForTran program. And yeah, this is a Pascal triangle is relevant to so many problems, including our physical chemistry NMR topic. But let us quickly see the features, salient features of this triangle. Well, it starts with and ends with 1. So everywhere you see the left and the right is 1, 1, 1, 1, and n plus 1 in the nth row. So if it is 2, then there are 3 terms. If it is 3, then there are 4 terms. So for n, it is n plus 1 terms, and it is highly symmetrical. So 1, 1, 3, 3, 1, 1, 4, 4, 6, and it is symmetrical. One value is maximum for n equal to even. So if n is even, so only one value is maximum, 6. But if n is odd, then there are two maximum equal maximum values, 10 and 10, and that is valid for throughout. So these are the salient features, and then we will again see. Well, other than binomial expansion formula, if I want to produce this Pascal triangle by simple different algorithm, that's a good exercise of for learning ForTran or any other language actually. So we will first plot the next, but we will first generate the Pascal triangle by some ForTran program. Okay, let us go for the program. So here I will see the Pascal triangle from well, I am forming a matrix, square matrix, but other than the relevant elements, it will all have 0, and that they will not write it. So basically it will write the Pascal triangle, but I have to give only the number of rows. How many rows you are asking for? N, read n. That is the only input it will want from you, and let us run it for say n equal to 10. That we have already produced by another program. Altogether this is a different algorithm we have used. You can try with without applying the formula binomial coefficients. So let me give 10 rows. So it gives, you see again 19, it's symmetric, 1936, 1936, 84, 84, 1, 2 values, 126, 126, right? So that is how we can produce the Pascal triangle. But my next question is that if I want to plot how it would look. Suppose I am plotting, these are the y values, 1, 2, 3, 4, 5, 6, 7, these are the x, 1, 2, 3, 4, they are x, and these values taken from the Pascal triangle are y values. So what would be the plot? Of course, there are some discrete values, so it would be better to see in terms of bar chart. So let me go for an Excel plot. So let me go for a Excel plot. So Excel Pascal. It will show quickly that how we can draw a graph in Excel as per my requirement. Here I want, suppose I want, here the results are already there. So let me just plot this n equal to 4. So 1, 3, 3, 1, that is the value, and I will just insert and data, and then insert and then bar chart. So I am asking for simply bar chart. So you see 1, 3, 3, 1. So this is how it gives you the plot. Let me keep aside it somewhere here, and I will go for say the 10 that I am producing by my program also. So I am asking now to plot the n equal to 10 value. So you see this is the n equal to 10 value. So again, if I keep it side by side, then it will be easy to compare. Again, you see it is highly symmetrical figure, right? It's symmetrical figure, and there are two maxima. Here also two maxima. So this is how we can plot and see that how it looks like the Pascal triangle's graphical representation, right? So that's okay. and you can similarly plot for higher value even, and here already I have plotted some value for 20, so it looks like this. And if you go from bar chart to the points and drawing the line, so it would look like this. So I am coming later on this particular figure. Well, so if I see side by side, so in 10, and then if you increase the number that you can easily do by Excel, the plot would look like this, n equal to 10. But the symmetry, you see, a beautiful symmetry is there in both the graphs. Well, even high, n equal to 1000, so they are very close, and almost it looks like a continuous curve, but actually there are some discrete values that we are plotting, that you have to remember. Well, my next river is gambling, tossing the coins. Is there any winning strategy? If you want to go for a bet on tossing coin, better not to. But okay, if you are aware of this thing, you can go probably bet to win something. Well, let me discuss the winning strategy. Let us take 4 similar coins, right? Unbiased similar coins. And for convenience, let me tell that H has a value, say +1, and tell just the opposite. So let it be -1. Fine. So what are the possibilities? That all 4 head, that is one possibility, and 0 tail. So the value is 4 into +1, that is 4. And it may be 3 head and 1 tail. So 3 into 1 plus 1 into -1, that means 2. 2 head and 2 tail, that would give you the total value to be 0. 1 head and 3 tail, that would give you -2, and 0 head and all 4 tails, so it was +4, so it would be -4. So this 1, 2, 3, 4, 5, there are only 5 possibilities that you can get with 4 coins if you toss. Now the question is, it can be anything. If you toss all the 4 coins, the result can be any one of these 5. So what you will bet on? Would you bet on -4 or -2 or 0 or +2 or +4? So the question seems to be ridiculous, that okay, it's all betting. How you can predict? That is not gambling. If you can predict, then it's not gambling. So the question is whether you can predict or not. So the question is in other way. If you play n times, say n equal to 1000 or 10,000 even, can you predict that is there any particular value most likely to occur? Okay, on a particular definite tossing, you cannot say what is going to be the output or outcome. But if you go for 100 or 1000, a big number of times, then is there any possibility that most likely out of these 5, which one is going to be the most likely occurrence? And if one such is there, what would be that value? Is it 4 or -4 or 0 or what it is? And then is there any order of likeliness of the 5 possible values, that one is most probable, next one is the next most, and so on. So these are the questions we have to explore if I want to have an winning strategy. And this lies in the concept of probability. So I am talking about most probable, most likely. So of course it hints to the subject of probability. So let us consider. Okay. So suppose you have thrown these 4 coins 16 times. Okay. So a total of 16. Now you have 5 possibilities. So 1, 2, 3, 4, 5. Suppose you have got the first, that is +4 value 2 times, and then 8 times the second one, and 4 times, 1 time, and 1 time. So 2 plus 8, 10, 14, 15, 16. So you have tossed it 16 times, and this is the ratio of the number of times that you get different possibilities or combinations, right? So this is one of thousands of possibilities, right? It can be anything. It can be anything like this. It can be like this. It can be even like this, or it can be like even like this one. So the question is, can you predict which one will bet on out of thousands of such possibilities, right? So the answer is this. Really, if you keep on betting on this particular ratio, that's 1, 4, 6, 4, 1, and that is your winning strategy. Definitely at the end of a huge number of games, you are the winner, right? So the question is why? Why so? That you are getting 1, 4, 6, 4, 1, this in this ratio you are going to get the outcomes, right? So this is the big question, why so? Well, let us answer the gambling game. So let us briefly review that we have started with arrangement, then binomial expansion, then combination, then we have seen the Pascal, all are related, and now we are going for yet another coin toss, and let us see how all they are related through a common thread. So the best possible combination is already mentioned, that these are the combinations. So we are calling it a new term frequency. That means how many terms, how many ways you can arrange. So 4 head, so it is only one way you can arrange, H, 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 H. So 3H and 1T. So 1T, either you can place it here, the last position, the next one, and the extreme left. So other than this 4, you don't have any other option. So your frequency is 4, and then 2H and 2T. So these are the 6 possibilities, and 4 possibilities, and again 0H and 4T, you have only 1 possibility. So these are nothing but somehow we are trying to connect this ratio 1, 4, 6, 4, 1 to the number of ways it can be arranged, right? This combination, MN combination, 4, 0, 3, 1, 2, 2, etc. Well, as per our binomial expansion pattern, it is a kind of h plus t whole to the power 4. So h4 plus 4hqt, that we are getting either from Pascal triangle or binomial expansion coefficient or arrangement, or using the combination formula, all the same. So the term is ncr h n to the power minus n minus r t to the power r, and our explanation lies in probability. So what is probability? We have to understand that. Then we can understand this basic problem. Well, probability of an event, that what is the probability of that particular event, is defined as the number of event, that particular event, by total number of events. Say for example, if I say that what is the possibility or probability that all 4 are head. So your answer would be, it is one way it is possible, and the total way is if you add sum up, you will get 16. So it should give you 1 by 16. So what is the probability of this combination, that 3 head and 1 tail? You will get the result 4 by 16. They are the probability of the corresponding event. And if you take the ratio, so if you take the ratio of these values, that means it give you 1, 4, 6, 4, 1. So actually all these are coming out of the simple but profound probability concept, right? Well, finally we are coming to our chemistry problem, random error distribution, any pattern out of random errors. So when we are in the lab, we are doing some experiment. Of course, we try to eliminate, being an expert and experienced experimenter, you will reduce all possible errors in your experiment, right? But still, whatever expert you are, some of the errors that you cannot really eliminate, though however they are very small maybe, but suppose the temperature fluctuation or sudden fluctuation in the air flow, and etc. So some of the random and that random errors are quite random, right? You don't have any control. Random means, strictly speaking, which cannot be predicted, right, beforehand. So that's why they are random. So really these kind of errors, you don't have any control over those errors, so they are quite random. And suppose, let us start with some example. In an experiment, for convenience, let us just see that there are only 4 possible such random errors, and they are called U for error, and 4. So either U or each of the types can take either plus or minus 1 value. That means either the value is slightly greater than expected or slightly lower, so plus 1 and minus 1 for each of the errors. So all or each U can have plus minus 1. Now what are the combination? It may so happen that all 4 are showing you plus values. So 4U plus. So the total value is 4 into 1 plus 0. So 4. And it may be that 3 positive error and 1 negative error. So it is 3 into 1 minus 1, that is 2. And similarly 2u plus and 2u minus, 1u plus 3u minus, 0u plus and all 4u minus. So the values are 4, 2, 0, minus 2, minus 4. So does it sound very similar to some other thing? Yes, of course, you have rightly guessed. This is exactly the coin toss problem, right? So the same question, which combination is most likely? So even if it is random, can you predict that out of these possible 5 values, what would be the most likely occurrence? Which combination? 4 minus 4, 0 plus 2 minus 2. Or the question is any order of those 5 possible values, order of likeliness, the same question. So the questions are the same, and of course the answer is also the same, like head and tail coin toss problem, and that all lie in the concept of probability. Well, if you plot, you will get this kind of curve, and it clearly shows that the value 0 is having the maximum, so you will get in majority this particular combination, that is 2u plus and 2u minus. So though they are random, but nature as it makes some pattern out of random or chaos, and that gives you a very beautiful symmetric pattern with a definite maximum value, right? That is quite interesting. I have already mentioned that this is Gaussian, I have not mentioned, I have mentioned only that this is a discrete distribution of this probability. You can call probability distribution, but not function, probability discrete distribution. But unless you can synthesize a frame, a function, then till then you cannot say that it is a continuous distribution. So for greater applicability of this concept, we need to have a continuous function, and that was done by Carl Friedrich Gauss, and that's why we call this Gaussian curve, or sometimes you call normal distribution. Okay. Well, another chemical problem, and that is the very important problem. Usually we get it in PG courses, but in AUG courses some NMR theory is there in our present curriculum. So the problem is, suppose you are visiting the spectra, NMR spectra, or rather PMR, proton magnetic resonance spectra of ethyl acetate. So this is the formula of ethyl acetate, and so many hydrogens are there, but if you analyze the equivalence of the hydrogen, then you will see that these 3 hydrogen are equivalent to each other, these 2 are equivalent to each other, and these 3 again are equivalent to each other, but these 3 sets of equivalent protons are different from each other. So naturally we are expecting 3 different peak, right? So here you will get HA, HB and AC. Well, where the peak will arise for HA, HB, AC, that's a different question. I am not going into that details, but my focus is not the position of the spectra or how many spectral peak would be there. Rather, my focus is on the further splitting of these 3 spectra. You see, this HA split into not really splits, it's a single peak, but HC gives you 3 peaks and HB gives you 1, 2, 3, 4 peaks. So I am not even interested in these peaks as such. Rather, my main focus is on the ratio of the peak height here or here. So A, B, say 1, 2, 3, 3 peaks. So final peaks. So what are the ratio of height or area ratio? These 3 or these 4, right? So that is my main question, and how these all things are connected to our present problem of discussion. So let us see. Again, this is very connected to NMR spectra and Pascal triangle we are referring to. In almost all the textbooks, it refers only that it is related to Pascal triangle. In some cases they don't explain actually. So let me quickly see. Well, we call them 3 peaks or triplet, and it may so happen that n equal to 3, and that means 1, 2, 3, 4. So n to n plus 1, 2 to 3, 4 to 5. So 4 to 5. Here we call pentate. And n is what? N is actually the neighboring protons. So the proton I am focused at, and n is the number of neighboring protons. So actually this is because of spin-spin coupling between 2 protons. So that n is number of protons, neighboring protons, and the proton NMR or PMR spectra we are focused at, that splits into n plus 1 number of finer peaks. So if n is 2, then it gives you 3 triplet. If n is 3, neighboring protons is 3, then it splits into 4, and so on. But the problem is I am basically focused at the ratio of these heights, right? And it is given by Pascal triangle. So a single proton is there, so it will give n plus 1, that is 2. So the ratio would be 1:1. If it is 2, is not here in this picture, it is here the triplet. That means if the neighboring proton is 2, then it would be n plus 1, that is 3, that is triplet. And this example this one, and the ratio here from Pascal triangle we get 1:2:1. So this is 1:2:1. And similarly for n equal to 3, we get a quadret, and the ratio is 1:3:3:1, 1:3:3:1. You see they are same, 3:3, and these are 1:1. And even for the next one, we get n equal to 4 quintet or pentet, and we get 1:4:6:4:1, 1:4:6:4:1. So all binomial expansion, combination, arrangement, Pascal triangle, tossing the coin, error distribution, and finally the NMR spectra, all are basically focused on the same pattern, right? Well, let us quickly, if you go into the physics of this quickly, then we can have some scope here. So a single proton is there, and you know proton also are spinning particles, so it can have a positive spin clockwise or anti-clockwise. That means we call spin up and spin down. So only one proton, so two possibilities, up and down. So these two spin states can interact with the concerned proton spin in two ways only, and they are 1:1, so you will get the ratio 1:1. And what happens when there are two protons? That means it corresponds to somehow a plus b whole to the power 2 formula, and a square plus ab, ba plus b square. How? Well, so two protons, the possibilities are that both are half plus up spin, and the other cases, one can be first one half plus up, second one down, and the first one down, second one up. But they are all actually the same value wise, spin value wise, they are the same. So all taken together we are getting 4, and here both are down. So if you have two spins, there are 4 possibilities, both are up, both are down, one up, one down, one down, one up. So it gives you a ratio of 2, 4, 2, and that means 1, 2, 1, and they are nothing but the coefficient of binomial expansion, 1, 2, 1. So NMR is nicely connected to all our previous problems. Well, as I mentioned you that the contribution of Gauss, Carl Friedrich Gauss, Gaussian distribution, and he could give this formula. It looks a bit tedious, a few terms. Well, it's a function of x, fx, x is here, but two parameters are there, u and sigma, and okay, 2 pi is there. So this is the expression, and we are supposed to get that pattern that we are looking at in the beginning from this equation. But the question is, well, what is this mu and what is sigma? How do these two parameters play their role? In other words, what are the significance of these two parameters, right? And by the by, a lot of contributions from different scientists, physicists, and mathematician there. It all started from Galileo, and then contribution from Pascal and Fermat, and then de Moivre, and finally it was by Gauss, and of course it was followed by Laplace later on. So now we'll try to see how this function gives a plot of that kind, and more importantly to find the importance or significance of these two parameters in terms of that function. So we'll go for Excel plot. Okay, so Excel Gaussian. Just a few seconds. Please bear with me. We'll see a beautiful graph of, well, here it is. So this is the expression. This is the expression of Gaussian function mu and sigma. Well, I have started from -5 to +5. I have -5 to +5. The x range I have given, you can change it, of course. And I have generated 50 points from within this range at an interval of 0.2. So 50 by 0.2 is okay. The range is -5 to plus, that means 10. So 50 by 10 is 0.2. Well, for this given plot, I have used mu to be 0 and sigma to be 1. But I don't know what they are actually. But let us analyze, having a quick glance at the plot, that well, 0 is here and mu is 0. So is it that there is some connection and that it is at the maximum position? Not only that, it is a symmetrical distribution and 0 is just in between. That means the average of these values, 50 values, would be probably 0. Maybe I am trying to predict. So in that line of thinking, you may connect your mu with the average value. Fine. And then one more thing from this pattern graph we can probably analyze, that well, the mean position is here at 0, and what more thing is that the spread or width of the distribution, width, that means on average, if it's a wider one, that means the values are far away from the mean values. So that means they are highly deviated from the average or mean value. That means the variance or standard deviation is high, right? So width is somehow connected to the standard deviation variance, and the mean is connected with this position or the maximum position. So I am giving some hint actually that maybe this sigma is somehow connected to the this one value connected to the width or variance or standard deviation. Well, it can take up many other values, 0 and 1, other than these two values, but in a standard format, if it is 0 and 1 respectively, mu and sigma, then we call it normal distribution. Otherwise, in general, it is a Gaussian distribution. So let us now play with these two parameters. Say mu is 0. Now I am putting mu is 1. So what I expect, as I predicted, if it is really so that it is the mean position, then it should shift the graph towards right. That means at one position. So here somewhere here it should be shifted. So let us see. Yeah. So the graph's maximum position shifts here somewhere 1. So that means we are right, that mu is connected to the average. Well, now sigma was 1. So let me change the sigma value. Okay. So let me give you say 0.5. So 0.5. Now if it is really true as I predicted that it is connected to the width or spread of the distribution, then it should be a synced one, right? This time the sigma is less, the variance is less. That means all the points are very close to the average one, minimum mean one. So let me check whether it shrinks or not. Yeah, you see the graph shrinks. So you can other way you can play, it was 1, so now let me give 1.5. So again by same thought, we are expecting that it would be wider in shape. Yeah, wider. Now if I want to come bring back the mean at 0, then you just put a 0 and you will get 0. Well, so now again you put 1, so you are going to get the same one, starting one, the normal distribution. So by a simple distribution of I mean plot of by this Excel, we can easily see that what really happens regarding the parameters of mu and sigma. One is connected to the mean mu, and sigma connected to the average standard deviation. So it's nice to see a Gaussian, and it connects so many things. Let me quickly give a few words on yesterday, today, and tomorrow of Gaussian distribution. Actually, this is a very famous film, Hollywood film, Yesterday, Today, and Tomorrow. The yesterday, we focused on the discovering the something, understanding something, developing something, and then probably extending and understanding the worth and beauty of those things, and finally to be able to application that we have already done with Gaussian distribution. And today it is in what not. Your class test marks pattern, commerce, economics, data analysis, computer sciences, artificial intelligence, and any science. You will see somewhere the application of Gaussian distribution and normal distribution. And what about the tomorrow of Gaussian distribution? Well, probably it would be effective in analyzing human affairs, which are something abstract, characteristics, and behavioral pattern of human nature. So this is the yesterday, today, and tomorrow. And so I would like to say thank you. Thank you for listening, and I'll request you to please come back with your comment and feedback. Thank you.